Okay, this is section 2.3. Use scatter plots to analyze data. So we're going to be learning about independent variable, dependent variable, and then we're going to be making a graph and creating a scatter plot. Okay, so the first thing we want to do before we can create a scatter plot is to make a table of values, right? Who wants to read the short little paragraph here? Yeah, go ahead, Chris.
Doctors and dietitians also tell people to eat smart. By choosing your food carefully, you can get the nutrition that your body needs while avoiding the less healthy types of fat and carbohydrates. You can use graphs to analyze the relationship between these nutrients and the energy content of common fast foods.
Okay, so we can create a table then of values of the different nutrients versus fat, carbohydrates, and energy. In the investigate, for some reason, they actually move away from the food example and they start talking about Martians. So they're doing an investigate here. In a science fiction movie, Martians land on Earth. The scientists in the movie notice that the Martians have small hands and thin forearms. The scientists measure the left forearm and left handspan of a sample of 10 Martians. The table lists these data. So first of all, based on what you guys know from 2.2, what type of data would this be? Anybody know? What type of data? Yeah, Patrick.
Primary?
Primary data. And why is it primary?
Because they collected it themselves.
Right, exactly, because they found it themselves. Very good. That's from 2.2. Okay. The example here uses a graphing calculator, which is quite old. We don't have these. But the basic idea is we can go through and answer some of these questions. So it says, what does the horizontal axis of the scatter plot represent? What does the vertical axis represent? Okay, so the horizontal axis, when we talk about a graph on a scatter plot, okay, this is the horizontal axis, and this is the vertical axis, and typically the horizontal is labeled as X and the vertical is labeled as Y. In this particular example, if we look at this table, okay, we have the name of the Martian. Do you think that's relevant to the graph at all? No. Anybody? No. So the real two things that we're looking to create the scatter plot with are the length of the forearm and the length and the left hand span. Okay? Which one do you think would go on the y-axis and which one would go on the x-axis? First off, sorry, before I ask that, does anybody know where or why you would pick something for the X and something for the Y? Anybody know that from grade 8, maybe? Yeah, Joey. Sorry? The smaller numbers on the X-axis, okay. Why did you say that? Oh, okay, so just because of the space on the page. Okay, yeah, that's a good point. However, that's not how we decide. And that's what we're actually going to learn in this lesson. There's a very specific reason why we choose the horizontal axis and why we choose the vertical axis for specific types of data. Okay? In this particular case, when we're talking about the left forearm and the left hand span, it's actually a really difficult question to say which one should go on the axis. And the reason why is because we want to know what is dependent on the other. Okay? So when we talk about horizontal axes, the two things, and vertical axes, the two things that we really want to talk about is the dependent variable and the independent variable. Okay? We all know what a variable is at this point? What's a variable? Dominic? Okay, good. It's a letter in an equation, but typically a variable can represent what?
A number?
Yeah, it can represent a number, or it can represent really anything, right? A variable is like a placeholder. So a variable could be height. It could be length of your forearm. Okay? When we talk about independent variable and dependent variable, we're actually talking about the two things we're trying to measure. Okay? So if we talk about, let's say, the height of a plant that grows. Okay, in grade 11, you guys are going to do a biology project where you plant beans. And you're going to measure the actual height of that plant based on time. Okay, there's going to be a graph that you're going to create. Where do you think you would put the time And where do you think you would put the height of the plant? Yeah, in the back.
I put the height as the y-axis.
Okay.
Time on the y-axis.
Okay, and why?
Because the y, well, because the height is like really tall, so plus why would you put it on the
Okay. So it's really tall, and why would you put it? Yeah, Dan?
So it shows the growth rate throughout the time that it was growing?
Yeah, both would show the growth rate. It's kind of natural for you guys to think of the height to go up and down, though, right? So maybe that's why you guys are thinking put it there. But there's actually a real good reason. Yeah, Joey.
Because the more time it has, the higher it grows.
Yeah, that doesn't really tell us why we would put it on the y-axis. Robin.
It's like the area of the trend, like the direction that the trend is moving, if you put it on another axis would be different.
It would just look weird, kind of, right? Is that kind of not the real answer for you guys at this point, right? It would look weird, right, if you put the time on the y-axis and the height on the x-axis, right? It would look a lot more natural if you put it this way around, right, where our y variable was height and our x variable was time, because then you would see some sort of progression like this. Agreed?
Yeah.
And that looks a lot better than if we were to put height down here and time here. So then as time went up, our height would actually go up. It would look a little different. Okay?
Sure.
No problem.
Thank you.
So that's what we're talking about here, dependent variable and independent variable. And we're trying to decide where we put one and where we put the other. The easiest way to think of it is which variable depends on the other. Okay? So with the height and the time, does time depend on the height of the plant? Time depends on no man. Have you guys ever heard that expression? It also depends on no plant. Time is almost always exclusively independent. Okay? Because time is something that runs, and the height actually depends on how long the plant's been growing. Does that make sense? So height depends on time. Time doesn't depend on height. Agreed? So which one is the dependent variable? Height, because it's depending on time. Does that make sense? That is the easiest way to think of it. Okay, and I'll go through example after example, and I tell you that's the easiest way. There's a couple other tricks I'm going to teach you, but that's the easiest way to know what's independent and what's dependent. Okay, which one depends on the other. Okay, so we're going to go through a couple of examples here. Let's see, example number 1. It says, identify the independent and dependent variable in each situation. Sorry, before I go on, the dependent variable is always on the y-axis. Okay? Dependent variable up and down. Okay? So I would write this definition right here. Dependent variable, a variable that is affected by some other variable. Or you might write dependent variable depends on the independent variable. And it is always graphed on the vertical. I'll put y in brackets because it doesn't always have to be y, but traditionally it's y. Vertical y-axis. Okay? Oh, sorry. You can tell me if I'm off screen, okay? So that's what I would have written down there for your notes, okay? There's your dependent variable. Now, independent variable is defined as a variable that affects the value of another variable. Okay? I wouldn't define it as that so much. Okay? I would say the independent variable is typically the variable you choose. Sorry, an independent variable is typically the variable you measure. the variable you choose and affects the dependent variable. Any questions about that? Okay, so we know there's two things. Dependent variable, independent variable. Dependent variable, which axis does it go on? Dependent, right? Yeah, Y, or vertical. Okay, independent, horizontal. Okay, you guys are going to get really good at this real quick. We'll see how easy it is. Does the outdoor temperature affect the amount of fuel needed to heat a house? So, we have two variables here. We're looking at outdoor temp versus fuel. Okay? So we're trying to make a graph here. And this is literally what your test is going to be on. Can you graph this? You're going to have data, right? You're going to have numbers for outdoor temp and fuel. You'll have numbers here, right? Whatever it is. And you're going to have to graph it now. You're going to decide what goes on the y-axis and what goes on the x-axis. Okay? So the question becomes, does the outdoor temperature depend on the fuel you use in your home? Does the outdoor temperature care about fuel that you personally are using?
Yeah.
Who said yeah? Okay, Robin. So the outdoor temperature is really based on the way the planet turns, right? And the clouds. And that rotation axis is actually what creates the seasons, right? The fact that we're on a tilt. Do you think all of that happening in space depends on how much fuel you put into your furnace at home? No, not at all. Believe me when I tell you, temperature outside does not care about what you're doing with your fuel. Okay? Now, if I reverse the question, does the amount of fuel you put in your furnace inside your house depend on what's happening outside?
Yeah.
Are you going to put more fuel in the winter?
Yeah.
Are you going to put less in the summer?
Yeah.
Obviously, right? So therefore, the dependent variable is what, Gerardo? No. It was a 50-50 shot, right, Alex?
Fuel.
Yeah, the fuel, because it depends on the outdoor temperature. Okay? I know it seems weird. It's a little reverse. You guys are going to get the hang of it, though. Okay? And there's some good ones in here. There's hard ones. I'll do one of my favorites. So you're playing a tournament, an NHL 16, whatever, Xbox tournament with your buddies. Okay? And you're measuring who's the best player. Okay? And you want to measure goals scored versus games played. Okay, right? So the tournament, some guys are going to play 3 games, some guys are going to play 4 games. You want to measure them. Okay? They're both different variables. Which one would you put on the y-axis and which one would you put on the x-axis? Okay, so the guys that hands up went up right away, they're probably already getting it, right? Miguel.
Goal scored is on the y-axis, and then games played.
Okay, and why?
Because your goal scored won't depend on how many games you play.
Exactly. Is your games played going to depend on your goals scored? No, that doesn't even make sense if I say it, right? A lot of the time it comes down to how it actually sounds. You can decide, right? My games plays depends on my goals scored. That doesn't sound right. My goals scores depends on how many games I play. That sounds right. Okay? So there you go. That's a good one. Is there a relationship between people's ages and their heights?
Yeah.
Okay, so your two variables would be people's age and their heights. All right, so which one's dependent and which one's independent? Jonathan.
The independent variable will be age, and the dependent variable will be height, since
That's right.
height depends on the first age.
Yeah, exactly. Your height is going to depend. If you're 2 years old, you're probably not going to be as tall as when you're 20, right? So your height is depending on how old you are. Your age depends on your height. That doesn't make sense, really, right? You got to kind of turn your head and think, what? That doesn't really make sense. But my height definitely depends on how old I am, right? You become 70, you're probably going to be a little shorter. You actually do shrink a little bit. Believe it or not, your spine kind of comes down and you're actually a little bit shorter when you're in your 70s than you are when you're in your 30s or 20s. All right. Does the amount of rain in a region depend on its latitude? Okay, so we have two variables again. What are the variables, Lucas?
X and Y.
No. In the example I just said. Sorry?
Rain and latitude.
Right, amount of rain and latitude. And what do you think would be the dependent variable, Lucas?
Rain would be the dependent variable
Yeah, exactly. Why?
because, like, rain would depend on the latitude that it's at and the latitude.
Yeah, and you guys know what latitude is, right? It's basically where the horizontal position we are on the Earth, right? Latitude 0 is the equator. Okay, we're at actually the 44th parallel, I believe. Toronto, or 43rd. Okay? 44?
Yeah.
Okay, yeah, I think you're right. You guys learn that geography?
Yeah.
All right, nice. Okay. So yeah, definitely the rain is going to depend on where you are. Where you are, the latitude lines, they don't depend on rain. Makes no sense. Okay? Starting to get easier?
Yeah.
All right. And these are some of the trickier ones. Most of the time, your variable is time. And it's almost always independent time. Okay? Like if you're measuring time and distance, right? How far someone has gone in a certain amount of time, 100% of the time is going to be your independent variable, right? Because your distance is going to depend on how long or how much time you've been traveling, right? That makes sense? All right. Let's do a couple more and then you guys are done. Everyone know what a scatter plot is? Okay, so you just have a table of values and you pick the y-axis and the x-axis and you put the point, right? That's a scatter plot. An outlier is actually a point that lies out of the norm, or it lies outside of the pattern. Okay, do you guys see this? All my points look like this, and then there's a point that stands way out on the side. That's called an outlier. And traditionally, when you're making like a line to kind of graph this now, you ignore the outliner. You don't try and draw the line. Have you guys heard of or seen line of best fit? If not, you're going to learn that, okay? Line of best fit is basically a line that goes through as many points as possible, trying to divide the points on an even number on the left side of the line and the right side of the line. So if we have a scatter plot that looks like this, my line would go right between them. Okay? That's a line of best fit. Now, if there was an outliner here, and say there was another point here, say it was like this. So I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I wouldn't draw the line to try to include this outliner. I wouldn't draw it like that. I just ignore the outliner altogether. And even though I misbalanced on either side of the line with points, that doesn't matter. You just want to go through the general pattern of the scatter plot. Okay, does that make sense? All right. So that's what an outliner is. It's a measurement that differs significantly from the rest of the data. In my own words, I'd say an outliner is a point that doesn't follow the pattern. Okay? Yeah.
You need to know this,
Of course, yeah. It's in the textbook.
like for a test.
Yeah, everything you need to know for the test, yeah. Okay. Example 2, draw a scatter plot. So we're looking at a skateboarder here, and we're given this data, the initial height and the speed. What do you think the initial height is? What do you think we're talking about there when we say initial height? Are we talking about how tall the skateboarder is? Chris?
Like how high he jumps.
No, not how high he jumps, actually. We could read the question and see, but yeah, Christian? Yeah, it's a ramp that he's starting at, okay? So it's the initial height of the ramp. And they say initial is the same thing as starting. So starting height, right? So it wouldn't be his jumping height, but it would be the start that he goes down. So identify the independent and the dependent variable. Joey.
Independent would be initial height.
The independent?
Yeah.
Agreed, okay, yeah.
And the dependent would be the speed.
The speed, yeah. This one's not quite as easy. So let's try our sentence again. The initial height depends on the speed. Almost sounds okay. The speed depends on the initial ramp height. That sounds better, right? The speed the skateboarder is going to go is going to depend on the initial height of the ramp he's going down, right? But the other way around, if we say the initial height depends on the speed, it almost sounds okay, but something's wrong, right? Why would the height of the ramp depend on anything to do with speed? It wouldn't. It wouldn't depend on it, right? You would create the ramp independently before even measuring the speed. Agreed? Does it start to make sense? So another couple tricks, if you're not sure, okay, we can say that the dependent variable is typically, because the independent can be as well, but the dependent variable is typically measured. And the independent variable is typically chosen. Okay, and so I'll show you how that would work with this example. The height that I'm going to go down, I'm going to choose the height to go down. And the speed he's going to go, I'm going to measure the speed. Make sense? So dependent, you're measuring. Independent, you're choosing. With the example with the plant, with time and height, growth height, I'm choosing the number of days I measure the plant. Independent. I'm measuring, literally with a ruler, the height of the plant. Make sense? I still think the sentence of just depends on is easier, but if you're kind of stuck, that's how you would think of it. All right, so here we can see the scatter plot is created. We can see that there's one outlier, right?